Hi all, my topic is Perceptron as a universal approximator. To understand this concept, we need to know what is perceptron. We can say perceptron is a single layer neural network, or multi-layer perceptron is called neural networks. It is used in supervised learning to help classify the given input data. So, perceptron consists of four parts. First one, input values. Second, weights and bias. Third, net sum. And fourth one, activation function. So, here in this picture, we have x1 to xn inputs and w0 to wn weights and a weighted sum and the output. Now we will see how it works. The perceptron works on these simple steps. The first step, all the input x are multiplied with their weight w. Let's call it k. Here in this picture, we have x1 to x5 inputs and w1 to w5 weights. So the first step is to multiply both the input with the corresponding weights. And the second step is to add the multiplied values and call them weighted sum. That is, in the first step, we added our inputs with the corresponding weights. Now, we'll add all these multiplied values and call it as weighted sum. And the third and last step is apply the weighted sum to the correct. That is, after the second step, we have the approximate value. Then the last step is to apply that value in the correct output. Coming to the universal approximation theorem, the theorem states that given any continuous function, it is possible to approximate that function with AI neural networks. That is, simply we can say that neural networks can approximate any continuous function and this result holds for any number of inputs and output. Here is an example. In this picture, there are two inputs, weight and height. According to the inputs, we need to find or we need to predict the gender of the person. We realize that h1 is a linear function of both weight and height with a parameter w1, w2 and the bias term b1. Therefore, we can mathematically express h1 as h1 equal to w1 into weight plus w2 into height plus b1. Similarly, we realize that h2 is a linear function of both weight and height and parameter w3 and w4 with a bias term b2. Therefore, we can express h2 mathematically as h2 equal to w3 into weight plus w4 into height. So that going along these lines, we realize that the output O1 is also a linear function of h1 and h2. Representation power of neural networks. Neural network has very strong representation power. Neural networks with single layer can represent any bounded function to a arbitrary degree of accuracy, and the neural network can represent any Boolean functions. So now we will check how we represent perceptron as Boolean gates. So in this picture we represent the OR gate, NOT gate and AND gate. The value in the circle are thresholds. The value on edges are the weight. A perceptron can model any simple binary Boolean gates. So perceptron is a strong representator. Then coming to the universal gates, perceptron as universal AND gate. In this we have x1 to xn inputs. The values of x1 to xl are all 1 and xl plus 1 to xn are all zeros. The universal AND gate only fire if x1 to xl are all 1 and the xl plus 1 to xn are all 0. And the threshold value of AND gate, which gives the mentioned input, gives L threshold value. Then coming to the next gate, OR gate, universal OR gate. It also takes x1 to xn n inputs. The value of edges from x1 to xl is all 1 and xl plus 1 to xn are all 0. And the threshold value is L minus n plus 1. L minus n plus 1. Then coming to the next universal gate, XOR gate. The perceptron is not enough to represent XOR gate. That is, it cannot compute an XOR. Then coming to multi-layer perceptrons. Multi-layer perceptrons are universal Boolean functions. We can compute more complex Boolean functions using multi-layer perceptrons. It is also called MLPS. MLP can compute any Boolean function. So, it is a powerful representer. So, thank you.